Welcome back to Let's Code. Today we are going into Sycamore even deeper. We're going to the TodoMVC example. Now here you can see that I'm running trunk. We have this application running on port 8080. I'm going to minimize that now because we don't really need it. And if I type into this something 1, 3, I don't know because I didn't count well. And then we can click these and we can filter. Hopefully we can filter. There we can filter. And then we can see completed, we can see active, we can see all. We can clear completed, etc. Although every once in a while, I feel like it doesn't quite. Okay, no, we're good. So all of that together, this is the example we're going over today. So this example exists in the Sycamore GitHub repo. So if you clone the Sycamore GitHub repo and you go into the TodoMVC folder, this is the application that we're working with. We've got 3 files here, which are real quick to go over. The first is the classic index.html file, which has nothing really interesting in it except for the to-do app MVC files, so the styles specifically, to make it look like all of the other TodoMVC apps. Trunk uses that to actually serve the application. Then we've got the cargo toml, and we've got a couple of dependencies in cargo toml. You'll see that because we're in the Sycamore GitHub repo, we're using a path dependency here instead of a crate version or something like that. We're pulling in the UUID crate with support for Serde v4 UUIDs, which are the right ones to use unless you know what the other ones are, and wasm bindgen support. We've of course got wasm bindgen and Serde. We're using log here, interestingly. It's interesting to me just because I see this every occasional project that I look at. It feels like the entire REST ecosystem is moving to tracing and has been for years at this point, but you still see log occasionally. And I think that's just because people are more comfortable with the way that log works historically. We haven't, as an industry, moved to observability and distributed tracing yet. That's not in the vocabulary of most engineers at this point in time. So I think that's why we see log here instead of tracing more often than not. And then we've got the classic console log and console error panic hooks, which are WASM necessities. Again, Sycamore requires Rust 2021, so we're using Rust 2021. And that's it for our cargo toml. And now there is only one file, it's source main.rs. So that's the file we'll be in for the rest of the video. First, we've got a struct that represents each to-do. This makes sense because they have a title, a completed state, which is that checkbox, and then some ID. In this case, they're choosing to use UUIDs, specifically the v4. There is also other versions of UUIDs, but v4 is probably the one that you're familiar with if you've used UUIDs in the past. And we derive a bunch of traits, serialize, deserialize, equality, things like that. We've also got filters. Filters, if you watch the view video on the TodoMVC, or not the view video, the U video on TodoMVC, this used a very similar filter enum, which is really interesting to see just because they chose to represent this filter as an enum in a very similar way. They both also chose to grab the URL from the filter enum itself. So by using this URL function, or by using this get filter from hash function, which goes the opposite way. So this is serialization to the URL and from the URL. It's interesting to note that the getting the filter from the hash, so this is a client-side application only. This isn't a server-side rendered application. So this will run in a browser with a window. And the WebSys window actually is not just the raw window struct. It is something like a result or an option. I don't actually know which one it is offhand, but you can see from this unwrap that it is wrapped here. And you can see from the type signature here, because I just typed it out, that it is actually an option. So it's not a result, it's just an option. But that's because, and you see this a lot in JavaScript as well, when people write code, they usually use window as a global, or they'll use document as a global, or they'll use something like location as a global. And that is only true in certain scenarios. So as people who develop web apps, we have a number of different runtimes that our application needs to work in. And that is not only browsers, which have their own selection of features that they support. Later on, we're going to talk about local storage. You could imagine a browser that doesn't have support for local storage because that wasn't always true. Not all of them had it. But you run into this problem in JavaScript where it's easy to try to access the window and then wonder why this component that you wrote that relies on the window breaks in a server-side rendered environment that doesn't have a window variable, or breaks in like a JS DOM or a fake DOM environment because it doesn't have a window or it doesn't support some feature. So while it looks awkward to have these unwraps here, I believe that it is doing more for us than we think it is. So this window is not guaranteed just because we're writing something that runs in a JavaScript related environment or a WASM environment. This window isn't guaranteed to be there ever, even in JavaScript. And a lot of people act like it is, and then they get confused when it's not available. So I like seeing these unwraps here, and we do the location hash. So we get the hash and then we just hash as string. If it equals this, then that. If it equals this, then that. I would expect if this were a larger application that we would be using more of a router. I don't think the Sycamore router is used here. This is kind of a manual parsing and setting of the URL. Then we get to app state. So app state is our global state. It has the to-dos for the entire application and the filter that we're currently looking at. These are all RC signals, which I find personally hilarious because signals are described in the documentation as being these things that are associated with a scope. And that's the reason that we're passing that CX variable that we'll see later all over the place. And then immediately, like the first state that we see in this file is an RC signal, which is a signal that is not bound to a scope. So it doesn't need that CX. But suffice it to say, we have to-dos, which is a signal. You can think of a signal kind of as like a place to put some state. So there's going to be a get and a set on that. And then we have a vec of signals that are to-dos. And we have the same thing for this filter. So we have a RC signal for the filter that we're currently accessing or using. We impl on app state for a number of different functions. So we've got add to do, remove to do, to-dos left, to do complete all, and clear completed. These functions are very similar to the functions that we saw in the U example. The only big difference here is that we're using create RC signal because the types in our app state are RC signals. So we're creating an RC signal with a to-do when we add a to-do. And we have to use this modify function to be able to modify the to-dos as well. It's especially interesting because you could, for example, have passed in a mutable reference here instead to this function, but the API for signals doesn't do that. It requires you to call this modify function instead. So a little bit of a departure from Rust's ownership model to support the signal API here. But overall, these other functions are more like regular Rust functions. So once we're done getting like some to do, for example, so we get the list of to-dos, we iterate over them, we fold here. Why are we folding? Okay, so this fold is basically like if we filter all completed and then count the ones that are left. Some people are more comfortable with folds. If you're not comfortable with folds, don't worry about it. You wouldn't have to write a fold here. You could filter out all of the ones that are completed, and then you could count the ones that are left. But you'll see this sprinkled around everywhere. So this reactive signal paradigm really infects all of the code that you're going to write. So anytime you access to-dos, you're not just going to access to-dos in like the way that you would in Rust. You're going to access the to-dos in the way that you would in Rust, but also you have to then call an additional function because the way that you accessed the to-dos in Rust didn't actually give you what you needed out of the to-dos. So you'll see a lot of like self.todos.get or self.todos.whatever in a bunch of different places, and it kind of just gets everywhere, which isn't necessarily a problem, just to be clear, but it does get everywhere. And then you'll see like .set here as well. So to do .set this to do. So in this case, this is just creating, or this is rather iterating over the to-dos, getting whether they're completed or not. If they are completed, setting them to uncompleted or making them active would be the right way to phrase that given the comment. So we kind of have like a reference to a to-do here, and we're setting the value of that to-do signal. So you get to see a little bit about why we are setting up our app state with RC signal and then like a vec and then an RC signal and then a to-do. It's because they act as wrappers to put state into, like containers. Here we've got the main function, which sets up some of the WASM stuff that you might have seen in the past. It sets the panic hook to be a WASM compatible panic hook, and then sets up console log specifically with the log debug. The interesting part for us is Sycamore render, which is a closure that gives you a context that you then need to use when you use view. So we get the context, we have the view macro to render our application. We have to pass in the context as the first argument to the view macro, and then we get to initialize our app. Our app is defined using a component macro. So this is an attribute macro that defines this function as a component. It is generic. So this G HTML is saying that the generic argument G implements HTML. A brief aside to show you what that HTML is, and it's a trait that implements is browser or has a const is browser and has a function called toWebSys. So the thing that we return has to implement this HTML trait is what we're saying when we use this generic here. So we've got a view which takes a type argument of a thing that can be turned into a node, basically. And then this is our context or our scope, which is everywhere in Sycamore. In our app component, we grab local storage. So we have to do the same window.unwrap because it's possible that the window doesn't exist here, and it's possible that local storage doesn't exist here. And in this case, we're choosing to basically not handle that case. So if we ever ran this on the server, for example, this would panic and fail, but it would panic and fail here at this unwrap, and we would know that it's panicking because it doesn't have access to a window. We grab or we store our to-dos in local storage along with the rest of the application state. So we do have to get it from local storage to be able to use it. It's stored in local storage as a JSON string. So we need to use ser.json to grab the string from local storage and turn it into JSON that we can actually use, or like turn it into a struct in this case that we can actually use. And we're basically saying get it from local storage or else create an RC signal with an empty array. So we either get the to-dos or we get an empty vec. And if we look at the types here, the types of to-dos is RC signal vec, RC signal to-do, which is the type of our app state, or the type that we use in our app state anyway. This app state is given to-dos and a filter. We have to create RC signal once again to create this filter or wrap this filter in its signal container so that we can put it into the app state. We provide that app state via context to the rest of our application. So we will see more components here. And this context, similar to the context in any other UI framework, in Vue, in React, in whatever. This context is a way of propagating something down the UI tree and then picking it up again in some child component that isn't directly handled by this app. So we'll see that again later. Then we've got create effect, which is, kind of similar to use effect. This is kind of like setting up some logic that will run for us. So I feel like we're programming a second layer of logic here. So we want to create an effect, right? And we get this context and we use a closure with move. So any variables that are captured in this closure will get moved in. We grab the app state via context. So we just had the provide context here. So that's basically what we're going to get. And then for each of the app state to-dos, we get them. We get all of the to-dos, that is. We iterate over all of the to-dos and then we track each of them. So what we're doing here is basically, I don't want to say implicitly, but we have this context that we're operating in here, this CX, and to-do.track will add itself as a dependency of the current context. So we're basically saying that, hey, we are going to want to do something whenever these change. And then this local storage will fire when those change. So we get local storage.set item with the key that we've hard coded earlier in the application. We serialize our app state to a string and we store it in local storage. So this is kind of like the reactive part where you've got this scope that follows you around everywhere. And this is why the scope follows you around everywhere, so that you can do things like this and say, hey, this is a thing that I care about. Let me know when this changes. And then down at the bottom, we have our view returned from application, which of course passes in yet another context variable. And then we start to see what the HTML actually looks like in more of a realistic application. The div here accepts properties inside of what looks like a function call. So it's like a div function call and then key equals value kind of vibe. And then we can nest children inside of that. So we've got section and copyright. And then we've got more attributes on section. So we've got the to-do app on section. And then we've got these header, list, and footer, effectively what look like empty structs almost. But it's like a header with an empty children. And each of those is a function or a component itself. So they're defined the same way. We get the function attribute macro, or the function attribute macro, the copyright, the component attribute macro to define the copyright component that returns something that implements the HTML trait that accepts a scope that you then have to pass into all your view macros or anywhere that needs the scope, and otherwise can just build out any HTML that you feel like building out here. The header is a little bit more interesting. Again, attribute macro for the component. Again, same function signature exactly, we can use context here to grab the app state from this scope, which will give us our to-dos and filters. So if we look at this and I don't whack the mouse, if we look at this, we get the app state, which has the RC signal, VEC RC signal to-dos, and the RC signal filter. So we can now use those values to do whatever we want. We can see the localized version of a signal here. So we've got a value that is a reference to a signal string that takes the context and creates a new string here. So we've got some value that we can do some manipulation on later. We've also got an input ref here, and we have to do that with a create node ref, which gives us, again, a shared reference to a node ref. And if you've used other frameworks, other UI frameworks, you may be familiar with this ref, but we're using it on the input here. And we're also using it inside of our event handler here. So this handle submit is being placed on the input, and it's not actually a form. So handle submit is a little awkward. We have some special syntax for responding to events. So in this case, on : key up, instead of say like the browser version of that with an underscore or whatever. Our handle submit takes the event. So on key up, we get a keyboard event because this is a key up event handler. This event.unchecked into is performing an unchecked cast into a keyboard event. So we're just kind of making this event a keyboard event here. It doesn't cost us anything to do, but it is a little bit awkward if you're used to more well type checked situations inside of the Rust programming language. We're just kind of saying, hey, we have an event and it's going to be a keyboard event. So from here on, we've redefined event to be that keyboard event, which means that we can check for the key and see if it's enter. If it is, so if we've pressed enter and it was released, then because this is the form for inserting a new to-do, we call this a task because it's one of the to-do items. We get the value, so that's the signal up here. I probably would have named this something else. It's a little awkward to talk about like tasks and values, but basically we're getting the value from the DOM element by binding it to that signal. So this value up here that we created a signal for, we have bound to the value of this text component or this input element. And when you release enter, then we fire this, we get the value out of that signal, which should be updated to be the value of the input element. And we're storing that in this task variable. We trim it because I guess you could have inserted a bunch of spaces before or after. And we say if it's not empty, so if it's not an empty string, then we add a to-do to the app state. This is one of the functions that we associated with the app state before. So this is a function that we defined earlier. We set the value back to an empty string because we've now inserted that to-do item into our app state. And then we use the input ref that we created to get the DOM node to not check it and cast it as an HTML input element and then set the value to an empty string. So there's a little bit of type unsafety here when dealing with the DOM directly. So we got rid of the virtual DOM, but we adopted like low-level casts between a thing that we have a reference to and what we want it to be. So a little bit of a trade-off here. I don't know if we can work around that somehow. I don't know if we can get more type safety out of that, but it does seem to be related to, because we don't have a virtual DOM inside of Sycamore, we do have to do this thing where if we get a DOM node, we have to cast that into some kind of HTML element. But other than that, it's basically the same for everything. We can use context to grab the app state context. We can create references. We can create selectors. So we can select little pieces of our app state and only update this value when that piece of the app state or that piece of the specific to-do gets changed. So completed can then be used to only handle one piece of our to-do. But that really covers most everything that is in this file. I think the only other thing to cover is when doing lists of to-dos, for example, you have to break out of this like pseudo HTML thing that's going on, and you have to start using some custom things here. So in this case, we're using keyed. We're passing in an iterable, which is the filtered to-dos in this case. We're specifying the view, like the HTML, using the view macro, but using this view field on this key thing. I'm not really sure what to call keyed right here in this context. And then the key is going to be specified as like to-do.get ID or something like that. So you kind of lose out on being able to iterate over things yourself in a way. And this really breaks the paradigm for me. It breaks like this. It's like a view macro. We're already passing in context everywhere. You're making it look like HTML and it nested similar to HTML. But if you handed this to somebody that needed to write front end code that didn't know Rust, they would have a really hard time right here with this keyed component thing. They might have an okay time up here because they've seen things like CSS before, you know, like with these braces and children and things like that. But the keyed thing sticks out to me kind of as like a sore thumb. It would be hard for me to onboard somebody who was used to writing HTML and CSS into using something like keyed. So that responsibility would live with whoever was writing this Rust application, and they would have to interface with somebody who basically gave HTML and CSS instead of this Rust code, which is something to keep in mind, right? Like this can be fine if you are working on this alone, or if you're working on a group of people who are willing to adopt and learn a syntax that is not used anywhere else, right? This is used inside of Sycamore exclusively, but it's going to work less and less well the more people you have on the team and the more roles they encompass. This was a pretty deep dive into Sycamore and what it looks like in more of a production ready application. I really like the TodoMVC examples for that. You know, TodoMVC isn't perfect, but the wide adoption makes it really easy for us to compare different frameworks in this specific context, which I really enjoy and appreciate. So thank you everyone who has put together a TodoMVC example, the U team, also the Sycamore team, so that we can even go between these and have a similar example to look at what it means to write Rust in the UI on the web. I hope you enjoyed this video, and we'll be back probably with more Sycamore stuff in the future. We still have quite a few things to go over. We kind of covered a lot of the reactivity today. We didn't cover server-side rendering or anything like that. And I hope you have a great day. See you in the next one.